Along in this lecture we will find out the area of a square. In the drawing we have triangle ABC. Triangle ABC is a right triangle. That is to say, this angle ABC equals to 90 degrees in its size. And we know that side AB equals to 5 units in its length. Side BC equals to 12 units. Inside this right triangle ABC, we have this square DEFG, and our mission is to find out the area of this square. Okay, so first of all, we find out the length of the hypotenuse AC in this right triangle ABC. So we'll use the Pythagoras theorem in order to find out the length of the hypotenuse AC. So in the right triangle ABC, by PT is abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the hypotenuse in this right triangle ABC is AC, and therefore the square of the hypotenuse is AC squared, and it must be equal to AB squared plus BC squared. Repeat again. In the right triangle ABC, according to the Pythagoras theorem, AC squared equals to AB squared plus BC squared. So AC squared, it is the square of the hypotenuse, equals to AB squared. AB equals to 5, therefore AB squared is equals to 5 squared, that is 25, plus BC squared. BC equals to 12, therefore BC squared equals to 12 squared, that is 144. In conclusion, we found out that AC squared equals to 25 plus 144. 25 plus 144 is 169. So AC squared equals to 169. Here we'll take a root out of this equation, and you get that AC equals to the square root of 169, that is 13. So if we found out that the length of the hypotenuse AC is 13 units. Okay, so what is down here that AC equals to 13 units. In the next step, we'll define this angle, the same angle alpha, and we'll focus on the right triangle ABC. On the right triangle ABC, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees, that is the sum of the angles in any triangle. We define 90 degrees minus alpha is beta, and therefore the missing angle here equals to beta. Here we have the equation 90 degrees minus alpha equals to beta. If we relate to this equation alpha and then we subtract beta, we get that 90 degrees minus beta equals to alpha. We also have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Repeat again. We have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. AC is the hypotenuse of the right triangle ABC, therefore it is absolutely a straight line. So if you focus on the lower side of the straight line AC at point D here, the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the lower side of AC at point D? We have this angle that is 90 degrees plus this missing angle that is angle ADF. In total, the sum of those two angles must be equal to 180 degrees. Therefore, this missing angle, angle ADF, must be equal to 90 degrees in its size. So this angle is the right angle. Likewise, if you focus on the lower side of the straight line AC at point E, here the sum of the angles must be also equal to 180 degrees according to the rule that I mentioned. The rule that I mentioned is the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the lower side of AC at point E here? We have this angle that is 90 degrees plus the missing angle. In total, it must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. So, in the right triangle, the small right triangle ADF, this small right triangle ADF, this angle equals to beta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus beta. Why? Because 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. So the missing angle equals to 90 degrees minus beta. But 90 degrees minus beta equals to alpha. Therefore, the missing angle equals to alpha. Okay. In the next step, we will focus on the right triangle, triangle GEC. On this right triangle GEC, this right triangle GEC, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta. Therefore, the missing angle here equals to beta. Here, BC, line segment BC is one side of the right triangle ABC, therefore it is absolutely a straight line. So BC is a straight line, so if you focus on the upper side of the straight line BC here at point G, so here the sum of the angles in the upper side of BC at point G here must be equal to 180 degrees. So which angles we have at the upper side of BC at point G? We have this angle that is beta, plus this angle that is 90 degrees, plus the missing angle. In total, they must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle here must be equal to 90 degrees minus beta. Why? Because 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles on the upper side of the straight line BC at point G. So the missing angle here must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha. We already found out that 90 degrees minus beta equals to alpha. Therefore, the missing angle here equals to alpha. So, in the right triangle, the small right triangle FBG, this small right triangle FBG, this angle equals to alpha. This angle equals to 90 degrees. Therefore, the missing angle here equals to 90 degrees minus alpha. but 90 degrees minus alpha equals to beta, according to our definition. So the missing angle A equals to beta. So in the drawing, we have in total 4 right triangles. 1, 2, 3, and the big triangle, triangle ABC. All the angles in those 4 right triangles are equal to each other. That is to say, in each right triangle, the angles that we have are alpha, beta, and 90 degrees. So all the 4 right triangles are similar to each other according to angle similarity rule. Again, repeat again. All the 4 right triangles are similar to each other according to angle similarity rule. And from the fact that the right triangles are similar to each other, we can derive a special relationship exists between their sides. For example, we know that the right small triangle FBG is similar to the right big triangle, triangle ABC. So I'll write it down. Triangle, the big right triangle, triangle ABC is similar to the small right triangle, this small right triangle FBG. They are similar to each other according to angle similarity rule. And from the fact that the 2 right triangles are similar to each other, we derive that the following relationship exists between their sides. But before that, we will define the length of side BG of this small right triangle FBG as x. So BG equals to x according to our definition. So what is the length of line segment GC? From the drawing it is very easy to see that GC equals to BC minus BG. Again, BC minus BG equals to GC. So GC equals to BC, that is 12, minus GC, that is x. So in total, GC equals to 12 minus x. So I write it down. GC equals to 12 minus x units in its length. In the next step, we define one side, the length of one side of this square DEFG as L. Here EG equals to L units in its length, and therefore all the other 3 sides must be also equal to L because of the fact that all the sides of any square are equal to each other. So DE equals to L, side DF of square DEFG also equals to L, and finally side FG of square FDEG also equals to L units in its length. Okay, so I repeat again that the big right triangle ABC is similar to this small right triangle, triangle FBG, according to angle similarity rule. And from the fact that the 2 right triangles are similar to each other, we will derive that BG over FG in the right triangle FBG is equals to BC over AC in the right triangle ABC, the right big triangle ABC. Repeat again. From the fact that the right big triangle is similar to the right small triangle FBG, we derive that the following relationship exists between their sides. We derive that side BG over side FG in the right small triangle FBG is equals to side BC over side AC in the right triangle ABC. Okay. BG is X. BG equals to X according to our definition over FG. FG equals to L. Again, BG equals to X and FG equals to L. And it is equals to BC over AC. BC equals to 12 and the hypotenuse AC of the right triangle ABC equals to 13 units in its length. AC equals to 13. In conclusion, found out that according to equation 1, X over L equals to 12 over 13. Here we will multiply this equation 1 by L, and we get that according to equation 1, X equals to 12 over 13 times L. Okay. And we also know that the right big triangle ABC is similar to this triangle EGC. Why? Because those two right triangles have exactly the same angles. The angles in this right triangle ABC is alpha beta at 90 degrees, and the angles in this triangle EGC are also alpha beta and 90 degrees. Therefore, they are similar to each other according to angle similarity rule. So write it down. The right triangle ABC is similar to the right triangle EGC according to angle similarity rule, and therefore the following relationship exists between the sides of those two similar triangles. Side GC over side EG in the right triangle EGC. Again, side GC over side EG in the right triangle EGC must be equal to side AC over side AB in the right triangle ABC. Okay. Okay, again, because of the fact that the right big triangle ABC is similar to the right triangle EGC, the following relationship exists between their sides. Side GC over side EG in the right triangle EGC equals to side AC over side AB in the right triangle EGC. Okay. So GC equals to 12 minus X over EG. EG equals to L. Again, GC equals to 12 minus X and EG equals to L, and it must be equal to AC. AC is the hypotenuse of the right big triangle ABC, and it is equal to 13 units in its length over AB. AB equals to 5 units in its length. So in conclusion, found out that according to equation 2, 12 minus x over L equals to 12 over 5. Okay? So in the next step, we first multiply this equation, equation 2, and we get that according to equation 2, 5 times 12 minus x equals to 12L. We have already found out that x equals to 12 over 13 L, x equals to 12 over 13 L, so we can substitute x in this equation 2, by 12 over 13 L from equation 1. We do it now and we get that according to equation 2, 5 times 12 minus x. X according to equation 1 is 12L over 13 and it's equals to 12L. So here we have 12 minus 12L over 13. So here we'll multiply 12 by 13 and then we divide it by 13 in order to have a common factor with this expression. And we get that according to equation 2, 5 times, inside the brackets we have 12 times 13 is 156. So in total, in the numerator of this expression we have 156 minus 12L over 13. And it is equals to 12L. So I said again on the relationship between the sides of those two right triangles. Again, we have AC over AB. So AC is in front of the angle of the right angle. AB is in front of angle alpha. And it is equals to GC. GC is in front of this angle that is the right angle over EG. EG is in front of angle alpha. So we have here GC that is 12 minus x over EG that is L, and it is equals to AC. Here AC equals to 13 units in its length, because actually AC is 13 and not 12. So here AC is 13 and AB is 5. So it is 13 over 5. Here also it is 13. And here we'll have 13L. So in conclusion, found out that according to equation 2, 5 times 156 minus 12L over 13 equals to 13L. Here we'll multiply this equation 2 by 13, and we get that according to equation 2, 5 times 156 minus 12L equals to 13L times 13 is 169L. So here we'll open the brackets on this side of equation 2, equation 2, and we get that 5 times 156 is 780, and 5 times minus 12L is minus 60L, equals to 169L. Here we'll add 60L to this equation, equation 2, and we get that according to equation 2, 780 equals to 169L plus 60, L equals to 229L. So here we divide this equation 2 by 229, and we get that finally that L equals to 780 over 229, and 780 over 229 equals to 3.40611 units. So L equals to L, that is the length of one side of square DEFG, equals to 3.40611 units. The length of one side of this square DEFG equals to 3.40011 units. And we know that the area of square DEFG equals to the length of one side squared. And we just right now found out. So it is L squared. The length of one side is L, so the length of one side square is L squared. And L equals to 3.40611 squared. So 3.40611 squared is equals to 11.6010 square units. In conclusion, we found out that the area of square DEFG is equals to 11.6016 square units. And that is the answer to the question. And put again, the area of this square DEFG is equals to 11.6016 square units. So in the next step, I will summarize the lecture. In this lecture, I found out the area of this square DEGF. So, in the drawing, we have triangle ABC. Inside this triangle ABC, we have this square DEFG. And our mission is to find out the area of this square DEFG. In addition, we know that triangle ABC is the right triangle, therefore this angle ABC equals to 90 degrees in its size. Side AB equals to 5 units in its length. Side BC equals to 12 units in its length. Again, our mission is to find out the area of this square DFGE. Okay, so first of all, we implemented the Pythagoras theorem in the right triangle ABC, in the right big triangle ABC. according to the Pythagoras theorem, in any right angle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the hypotenuse in the right angle ABC is AC, therefore the square of the hypotenuse is AC square, and AC square it must be equal to AB square plus BC square. Repeat again. In the right triangle ABC, according to the Pythagoras theorem, according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, so here AC is the hypotenuse, therefore AC, the square of the hypotenuse is AC square, so AC square equals to AB square plus BC square. AC square equals to AB square plus BC square. So AC square, that is the square of the hypotenuse, equals to AB square. AB is 5, therefore AB square is 5 square, that is 25, plus BC square. BC is 12, therefore BC square is 12 square, that is 144. So in conclusion, we found out that AC square equals to 25 plus 144. 25 plus 144 is 169. So AC square equals to 169. We took a root out of this equation and finally found out that AC, the length of the hypotenuse AC is equals to 13. The hypotenuse AC equals to 13 units in its length. Okay, in the next step, we defined this angle, angle alpha, that is to say angle ACB equals to alpha according to our definition. Then we focus on this right big triangle, triangle ABC. In the right big triangle, triangle ABC, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees, that is the sum of the angles in any triangle. So the missing angle here must be equal to 90 degrees minus alpha. But we defined 90 degrees minus alpha as beta, and therefore the missing angle here equals to beta. Okay, so in the right triangle ADF, in the small right triangle ADF, this angle equals to beta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha, therefore the missing angle here must be equal to alpha. Okay, then actually before that we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. AC is the hypotenuse of the right triangle ABC, it is absolutely a straight line. So if you focus on the lower side of the straight line AC here at point D, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have here? In the lower side of AC at point D, we have this angle that is the right angle, plus the missing angle here. In total, they must be equal to 180 degrees. Therefore, the missing angle here must be equal to 90 degrees in its size. Likewise, if you focus on the lower side of the straight line AC at point E, here the sum of the angles must be equal to 180 degrees. So which angles we have here? We have this angle that is the right angle plus the missing angle. In total, they must be equal to 180 degrees. Therefore, the missing angle here must be equal also to 90 degrees in its size. Then, in the right triangle ADF, this angle equals to beta, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha, therefore the missing angle here must be equal to alpha. Likewise, in the right triangle AGC, this angle equals to 90 degrees, this angle equals to alpha, therefore the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta according to our definition, therefore the missing angle here must be equal to beta. Then we focused on the upper side of the straight line BC at point G. Here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of BC at point G? We have this angle that is this angle beta, this angle is angle beta, this angle equals to 90 degrees, plus the missing angle. In total, the sum of those three angles must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle here must be equal to 90 degrees minus beta. Why? Because 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees is equals to 180 degrees. That is the sum of the angles on one side of a straight line. So the missing angle here must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha, therefore the missing angle here must be equal to alpha. So in the right triangle, small right triangle FBG, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta, therefore the missing angle here must be equal to beta. So actually, we found out that all the four right triangles in the drawing, we have in the right triangle, in the drawing we have four right triangles. 1, 2, 3, and the right big triangle, triangle ABC. Those four right triangles, they are all similar to each other according to angle similarity rule. Why? Because each right triangle has three identical angles, alpha, beta, and 90 degrees. And therefore, all the four right triangles are similar to each other according to angle similarity rule. And from the fact that those two, all those four right triangles are similar to each other, you can derive that a special relationship exists between their sides. So here the right triangle, the right big triangle, triangle ABC, is similar to this small right triangle, triangle FBG, according to angle similarity rule. And therefore the following relationship exists between their sides. Side BG over side FG in the right triangle BGF equals to side BC over side AC in the right triangle ABC. I repeat again. Because of the fact that the right big triangle ABC is similar to the right small triangle, triangle FBG, therefore BG over FG in the right triangle BFG must be equal to BC over AC in the right triangle ABC. BG is X, FG is L, BC is 12, AC is 13. Conclusion found out that according to equation 1, X over L equals to 12 over 13. Here we multiply this equation 1 by L, and finally found out that X equals to 12 over 13 L. So according to equation 1, X equals to 12 over 13 L. Likewise, the big right triangle ABC is similar to this right triangle FEGC according to angle similarity rule. Therefore, the following relationship exists between the two those two triangles that are similar to each other. Side GC over side EG in this right triangle EGC is equals to side AC over side AB in the right triangle ABC. Repeat again. GC over AG in the right triangle AGC equals to AC over AB in the right triangle ABC. GC is 12 minus X, EG is L, AC is 13, and AB is 5. In conclusion, found out that according to equation 2, 12 minus X over L equals to 13 over 5. Here we cross multiply this equation 2, and found out that according to this equation 2, 5 times 12 minus X equals to 13L. So here we open the brackets on this side of equation 2 and found out that before we open the brackets, we have here 5 times 12 minus X equals to 13L. So we have here X. But according to equation 1, we already found out that X equals to 12 over 13L. So we can substitute x in this equation 2 by 12 over 13L from this equation 1. We did it and found out actually that according to this equation 2, 5 times 2L minus x, and x according to equation 1 is 12 over 13L. So we substitute x here by 12 over 13L from equation 1. So this is x, and it is equal to 13L. Then we have here 12 minus 12L over 13. So we multiplied 12 by 13 and then we divided by 14 in order to have a common factor of this expression. So 12 times 13 is 156. So in total, in the numerator of this expression, we have 156 minus 12L. Then again, in the numerator, we have 156 minus 12L divided by 13 times 5. And it is equal to 13L. Here we multiply this equation 2 by 13. And found out that 13 times 13L is 169L. And it is equal to 5 times 156 minus 12L. So here we opened the brackets on this side of this equation 2, and found out actually that according to equation 2, 5 times 156 is 780, and 5 times minus 12L is minus 60L. Is equal to 169L. Here we added 60L to this equation 2, and found out that according to this equation 2, 780 equals to 169L plus 60L is 229L. So in conclusion, found out that according to equation 2, 780 equals to 229L. Here we divided this equation 2 by 229, and finally found out that L, that is the length of one side of square DEFG, equals to 780 over 229. 780 over 229 equals to 3.40011 units. So L equals to 3.40011. This is the length of one side of this square DEFG. And what is the area of a square? The area of any square equals to the length of one side squared. According to our definition, the length of one side of this square DEFG is L. Therefore, the length squared is L squared. Or the side square is L squared. And we already found out that L equals to 3.40011. Therefore, L squared is 3.40011 squared. And 3.40011 squared is 11.6016 square units. In conclusion, found out that the area of this square DEFG is equal to 11.6016 square units. Okay, thank you very much.